Okay, so in video 4, we're dealing with decision trees and more splits. Okay, just a little bit more splits. And the thing is, we could have split this in even more directions. As I was preparing for this, I was like, okay, we could have added an additional explanatory variable and then did a split there. But I would say that this direction is the best next step. And then have you all utilize the pre-made functions within Python. Okay, so again, I don't need this, but I still have this. Okay, fine. And so this situation here in particular, I am. This is the same data set. This is the same 10 values. I copied and pasted. Look at that. Same 10 values, is fine. I'm just gonna run it still. Hopefully, it doesn't give me giving me any issues. Okay, it's fine. Good, fantastic. Here, I'm creating a Gini index function. It's a little bit more simpler here because I'm, how do I say? I am, yeah, it's just a little bit more simpler here. Just note that, okay? Because I'm going to do more splits eventually. That's what it is. Sorry, my apologies. Okay. So I'm going to do more splits. And so then here, this functionality, this is at the end of the day, find the Gini index at a split and then actually calculating the weighted index for that particular split. So it's going to be doing because you can imagine I'm going to do a bunch of splits. I'm going to make this make sense in a moment. I'm going to be doing splits, but I have to find the weighted index at each one of those splits. So ideally, I don't want to have run this over and over again when we did in video 3. I'm going to have a function that does it for me. So I'm going to go ahead and run this, okay? And I'm gonna make sense of step 2 and step 3. These two functions, Gini index and evaluate splits, and I'll evaluate splits in one moment. Right now, actually, I think. Yeah, right now. So here we have split points. So this is actually a really important thing for me to mention what is occurring here. So this is what I was saying before regarding what a machine learning algorithm this decision tree is actually doing. It's going to find all the possible split points and find the weighted index for each and every one of those split points. So here, since our numbers are in terms of splits, we have GPAs 1 through 4. Why is it not auto completing? Why are you not? Okay. I don't like typing. Alright. So once I print this, it should show 0. It should show 1, 2, and 3. And 4. 1, 2, 3, and 4. Alright. So what's going to happen is going to say, okay, fine. Split the data set based off of all the GPAs being 1 or less. Okay, so it's going to be all the 1s and then 2, 3, 4 in another group. Then at 2 is going to say 2 or less. So 2s and 1s are going to be one group, and then 3s and 4s are going to be another group. Then it's going to be 3 or less. It's going to be 3. You get the point. 3s, 2s, and 1s are going to be one group, and then 4s are going to be the next. And you can imagine the split at 2 should have the smallest weighted Gini index. Okay, because here is from before, all the yeses are 3s, and all the 3s and 4s are yeses, and all the 1s and 2s are nos. Alright, so we're gonna, I think I already ran that's good. Okay, so then when I run this now, I'm gonna take this out because. So what I'm giving, and because I'm not trying to really spend time on the syntax of the Python, I'm really just trying to get you all to understand the concept of decision trees. I'm giving it the status, data frame. I'm giving it the split points. So it's going to split at each 1, 2, 3, and 4. And I'm telling the labels, the GPA explanatory variable is GPA, and the actual status is our response variable. Okay. And I'm going to uncomment this. Okay. Just a little OCD, that's fine though. Let's see what our results say. So here, split out 1, the Gini index for group 1, Gini index for group 2 is said 0.4 and 0, okay, because it's all 1s in one group. And here, the Gini index is 0.2857. As I said before, at 2, when it's going to be 1s and 2s in one group and 3s and 4s in the other group, the Gini index is 0, right, because it's the most pure. Okay, and then here, because threes, twos, and ones, and all in one group, split at 3, you're going to have a Gini index for one group 0.48, and it's the same thing as before because it's the same size, same sample size. And then Gini index is 0 because all the 4s are now labeled as yeses. And then now finally we go back to, not back to, but the situation 0.5 where we have 1, 2s, and 3s being labeled as yes, as no's, and then where those 3s are, you're going to have an issue with that. Okay, so that is what we see here. And so there's some more detail going on in terms of this. This is not that complicated if you compare it to what we've done in the past. It's just put it in a function format, which is fine. That leaves place for questions. You can have questions, okay? All right. Thank you all and have a great day. Oh, recap, Emmanuel, recap. All right, so recap, going through this, we have the same data frame from before. Yes, of course. We have two functions. One function is used to create the Gini index. The second function is used to create the actual, find the weighted Gini index for each and every split. Okay. And then from there, we're actually doing split and then finding the corresponding weighted, find all the possible splits. And then we're evaluating the results, getting our results. And then we're actually seeing what the actual split would be. Sorry, the weighted Gini index for each and every split. That makes sense. Got ahead of myself. All right. So now we're done after the summary. Okay, after the summary. Okay, good job.